This video is part of the certification program, SABA, Spreadsheet Applications in Business Analytics. Please contact if you want to apply for the certificate program, or for more details.
Now, one descriptive statistics we have not done is kurtosis and skewness. Okay, so remember I said that you have central location is first moment, dispersion is second moment, the third moment in statistics it is called as skewness. Okay, now what is skew? Skew means biasness. Okay, biasness, or if you go to the dictionary meaning of skew means something which is not proper. Okay, like health is not proper or whatever, like it's biased, right? So ideally we want a data set to have a skew of 0. Okay, that is, when it skew 0, it means that the data is symmetrical. That is, the mean, median, so mean, median and mode are at the same point. Okay, or skewness will mean that mean is dividing the part into exactly 2 parts. Okay, when skew is 0. But in reality, skew is never 0. Okay, most of the time it will be either positive value or it is negative value. Okay, right? So we'll see how this positive negative comes, but then skewness is called as third moment. So we have to understand this skewness, how it comes. Skewness, it comes by taking the deviation, cubing it. Okay, taking the summation of that and doing some more calculation, like taking the standard deviation, making it cube, etc. I'm not worried. What I'm worried is skewness is proportional to deviation cube, okay, and summing that. Now when you're cubing something, some deviation will be positive, some deviation will be negative. Okay, so that means the summation can be positive or the summation can be negative both. So that's why skew can be positive and negative both. Okay, skew will be 0 only if they are equidistant. As an example, okay, so we compute skewness here of our data set. Okay, so skewness, the formula is this, the function is skew. So you just give these numbers, so skew will come. So this is a highly skewed data set. Why? Because you see that it has a very large numbers. Okay, these are extreme values, okay, which are coming to the right. Okay, so if the extreme values comes to the right, so I'll show you what happens. This is the normal case, okay, when the skewness is 0. So it is, this mean is properly dividing the data set into 2 equal parts. Okay, but let's just suppose, okay, as an example, this is typically happening in the business schools. So since you guys are second year students, you know that companies will offer in the placement some salaries. Okay, now there are some students who have some experience, who are in the business school, or they are very good. So companies, they will give them a very high salary. Okay, so because of very high salary, what will happen is the average, it will get skewed to the average will shift. So the average will shift. So this is the new average, new meaning. Okay, it shifts. Okay, and we say that this data set, it skews and it has positive skew. Okay, so please note that in case of skewed data, average is not a good measure. We should not take average, right? So in case of skewed data, median is a better measure of central tendency. So that's why most of the business schools, they will report median salary packages rather than average salary packages. Okay, that is a better measure, and because of the skewness of the data. So our data, this data is positively skewed. Okay, let's see this data. Okay, we have one more data, and we see that this is a slightly negative skewed. Okay, so slightly negative skewed is this data, right? And whereas this data is like a positive skew because of the values which are extreme to the right side. In case of negative skewness, where the values will come, the extreme. So in the case of, so in the extreme side, like if you have lot of values are coming here. Okay, so suppose in an exam, okay, if you take, let's say, exam marks of this all competitive exam like IIT, CAT, etc., you'll see that the data will be negatively skewed, because there are a lot of people who are just sitting in the exam for the sake of it. So they will score very less number, very less marks. Okay, so the data gets skewed in the negative side, and then the mean, okay, the mean will be lesser there, right? So normally we say this, okay, in case of positive skewed, mean is greater than median, okay, greater than mode. Please note that in our case it is not happening. Okay, it is happening slightly. Mean is greater than the median, but it is not greater than the mode, because mode we just twisted something, but mean is greater than the median, right? And here if we compute the median, so see this, in case of negative skewed data, mean is typically lesser than the median. Okay, right? Mode we can't say. So even if we compute the mode, okay, mode single, okay, in this case mode was 78. It is just sitting. Okay, so in case of positive skew, mean is greater than the median. We can see here, confirm mean is greater than the median. In case of negative skew, mean is less than the median, which is less than the mode. Okay, this typically it is like, maybe like we can't just say by seeing the one of the data set. It is like just by chance it has happened here. Okay. Okay. Now, what is the fourth moment? Okay, so now you have understood how we computed the third moment. Third moment we computed by cubing the values. Okay, deviation values we cube. So fourth moment we compute by taking the fourth power of the values, summing it up. And then there are other things like a standard deviation to the power 4, etc. I don't worry. Okay. Now you tell me what is this? Xi minus x bar to the power 4. Can it be negative anytime? Is it possible to have this negative? No, it can never be negative, because it is power of 4. So this fourth moment will always be positive. Okay. And this fourth moment is called as kurtosis. So kurtosis is a measure of peakness of the data. Okay. So how peaked is the data? So as an example, if we have a distribution like this, and I have a distribution like this one, I will say that, okay, the blue one is more peaked than the red one. So the kurtosis of the blue one is higher than the kurtosis of the red one. Okay. So, but if somebody asks you, can kurtosis be negative? What will be your answer? No, kurtosis can never be negative. Can kurtosis be 0? Yes. Right? Now we'll see this. We'll compute the kurtosis of our data set. Okay. So say Excel gives you cut, and we compute. Okay. So here it comes as 2.69. Okay, and let's see here what is the kurtosis. See this. I just said that kurtosis cannot be negative, but here we are seeing that kurtosis is negative. Okay. What is the problem? Okay. I just said that kurtosis is to the power 4. This power 4 means it's always positive. Okay. It is again the problem with Excel. Okay. What Excel does is Excel computes something we call as excess kurtosis. Okay. So for this, okay, we need to know what is the kurtosis of a normal distribution. The kurtosis of a normal distribution is 3. Okay. So what the Excel do is, when it is computing a kurtosis, it computes the normal kurtosis and it subtracts 3 from it. Okay. Because it says that since the normal distribution has a 3 kurtosis, related to the normal distribution, what is the kurtosis? Okay. So this kurtosis which you are seeing negative, it is with respect to the normal distribution. Okay, so normal distribution has 3 kurtosies. It has standardized it to 0, and it is saying that this has lower than the normal kurtosies, normal distribution. So if you want to get the actual kurtosies, you just add 3. So this is your kurtosies. In this case, the kurtosies will be adding with the 3. Right? So Excel gives you wrong kurtosies. Always remember to add 3 in the Excel kurtosies calculation. It always gives you excess kurtosies. So always remember to add 3 on that. Okay. So that is one way you can compute. Okay. So we have actually covered almost the entire thing. Okay, but all of this you will be finding I have to remember so many formula, right? So I would say I will recommend you to not mug up any formula. You go to the formula bar, go to the more function statistical. You have every formula is up present here. Where p, okay, small, skew, okay, large will also be there, max, mean, everything is there, cut, everything is there. Okay.
This video is part of the certification program, SABA, Spreadsheet Applications in Business Analytics. Please contact if you want to apply for the certificate program, or for more details.